All right, so we're going to be reviewing the second unit of work that you guys did. And what this had to do was with similar triangles. Now, if you remember with similar triangles were two triangles that more or less were the same exact shape, just different sizes. A very simple explanation would be, let's take an equilateral triangle where every single angle is 60 degrees. Now, if every angle is 60 degrees, that means this is the exact same shape. One's a bigger or smaller version of the other. And the main thing to remember about similar triangles is sides are proportional. Let's say this is 5, 5, 5, and this is 2, 2, 2. This is a really simple explanation, but you could take two sides, let's say the left side and the bottom side, 2 over 2, and set that equal to the left side and the bottom side of the big one. And when you cross multiply, a couple things have to happen. When you cross multiply, they have to equal each other. The cross products have to equal each other, or has to have the same scale factor. So the way you figure out what the scale factor was is you would say, take the old side of 2, multiply it by your scale factor, let's call it x, equals this side, 5. So if you divide by both sides of 2, your x equals 2.5, or 5 over 2. What that means is this is 2.5 times the size of this. This is 2.5 times the size of this. Or this is 2.5 times smaller than this side. That's called the scale factor. Both of those ways were to figure out if two triangles were similar or not. And then what we looked into a little more in-depthly was whether two triangles, if they're similar, what makes them similar. And then we went over 3 different ways to figure out if they're similar or not. The first way to figure out if they were similar was if 3 sides of one triangle are proportional to 3 sides of another. Let's take a 3, 4, and 6, and let's say this is 15, 20, and 30. Obviously, this isn't drawn to scale, but technically, if this is similar, I could take, let's say, 3 over 6. Is that the same thing as 15 over 30? Yeah, for sure. 3 over 6 is 1/2. 15 over 30 is 1/2. Or let's do 3 over 15 equals, let's say, 4 over 20. Let's take the left side of each and the bottom side of each. And when I cross multiply, 60 is equal to 60. Or, doesn't matter how you do it, you could say 6 times 5 is equal to 30. Is 4 times 5 equal to 20? Is 3 times 5 equal to 15? Yes, they have the scale factor, so technically all 3 sides are similar or proportional to the other 3 sides. Saying side, side, side makes them similar. Now, remember, side, side, side doesn't mean all 3 sides are congruent. It just means they're proportional. The next thing we did was side, angle, side. All right, here is a triangle. Let's say this is a bigger triangle. And let's say there is some congruent angle in between these 2 sides. Let's say this is 8 and this is 10. And let's say this is 24. I don't know. Let's say this is 30. If you have 2 sides coming down and the point where they meet, that vertex angle is congruent on both of them, and if 8 over 10 is in fact equal to 24 over 30, and they have an included angle, that means they're similar from side angle side. So look, 10 times 24 is 240. Does that equal 8 times 30, which is also 240? Yeah, They equal each other. So these two are similar because of side, angle, side. Or you could say 8 times 3 is 24. Is 10 times 3 30? Yes, the scale factor is the same with two sides that come down with an angle in between them. Okay. There was one more that you did. And this was the easiest one. This is the one that everybody liked. It's called angle, angle. Angle, angle is if you can prove two angles in one triangle are congruent to two angles in another. So let's say these two angles are congruent to, even though this shape is bigger, the angles are still the same angle. If these two angles are congruent to these two angles, then by default, 180 minus these two would have to give you the same answer as 180 minus these two, making your third angle congruent by angle, angle. So these two would be similar because of angle, angle. Remember, all similar is two sides are proportional. It pretty much means same shape, but most of the time they're different sizes. Now let me ask you guys a question. What is the scale factor if you have two similar triangles where the ratio is 1 to 1? What do you, let's say this. The scale factor is 1. What do you know about two triangles whose scale factor is 1 to 1? Think about it. Here's a triangle. Here's another triangle. Whatever this side is, if I multiply it by 1, I get this. Let's say this is 10. This would be 10. Let's say this is 20. And the scale factor is 1, 20. Let's say this is 3. 3 times 1 is 3. This would be a triangle, two sets of triangles that are similar because they're you can prove that they're proportional by all three sides, but they're more than similar. If you have a scale factor of 1 to 1, that means the two triangles are congruent as well. All right, and then we did some word problems that had to do with similarity. Similar triangles with word problems. So let me look at my computer. Let me just pull one up really quick. One that's probably pretty simple. Okay. Okay, let's say you have a building and you have two different ladders. Let's say here's a building and let's say here's this ladder is 35 feet. And let's say there's a smaller ladder on the same building. Here's the ground. The way this works, this is always a right triangle. Let's say this is 25 feet up from the ground. The bigger ladder is 25 feet up. Let's say the smaller ladder is 14. It's this angle and this angle. It's leaning in the same angle. How high is this ladder right here? And the way you set this up is you just redraw two triangles. So let's take this triangle. This is 35. This is 25. And let's take this little triangle. This is 14. And this side is x. These two triangles are similar because of, watch, angle, angle makes them similar. This angle is the exact same angle as this because they're resting against the same. The incline is exactly the same, and they both have this right angle. So angle, angle makes them similar. You can just set it up. 35 over 25 equals 14 over x. Or 35 over 14 equals 25 over x. And then cross multiply to solve. Couple other things. You were taught let's take it had to do with a parallel line going through a triangle. And you were taught that this little triangle right here, if these two lines are parallel, is similar to this triangle because look, let's take two parallel lines from last year in Math 1. This angle and this angle are called corresponding angles. If these two lines are parallel, the corresponding angles are congruent. Well, let's extend this up and let's take this other line, a transversal that goes through it. This angle and this angle are called corresponding angles, and they're the same. Well, look, this is this shape. See, this angle and this angle are congruent. This angle and this angle are congruent. So therefore, because of angle, it's called the triangle proportionality theorem, where this side over this equals this side over this. So for example, let's say this is 15, and this is 24. This is 10. How would you find x? The way that you would find x is you would just set up a super easy proportion. Let's take 15 over 10 equals 24 over x. And cross multiply to solve. Or you could do this. You could say 15 over 24 equals 10 over x. Watch, no matter how you do it, you see how you're doing 24 times 10 equals 15 times x. Look, 15 times x equals 24 times 10. No matter how you set it up. The one that kind of gave people a little trouble is when you were given the bottom side. So for example, let's change this. Now, let's say they tell you let's take a triangle and they tell you that these are parallel. Let's say this is 3 and this is 7 and this is 5. And they want to know how big this side is. And this is a really common error that people do. They'll do this. They'll say 7 over 5 equals 3 over x. And I understand how people think like that, but that's incorrect. And let me show you why. Once again, you know that these two angles are congruent and these two angles are congruent. So therefore, you can draw, what I'm going to do is I'm going to draw this little triangle right here. This is 7 and this is 5. Now I'm going to draw this big triangle. This is 7 and 3, so this whole side is 10. This side is x. Now you have two different triangles. 7 over 5 equals 10 over x. See how that's different? It's not 7 over 5 equals 3 over x. It's 7 over 5 because you're using this left side over this bottom side. And then you're using the whole left side of this big triangle over the whole bottom side over 10 over x. That was what gave people some trouble, were a question like that, was questions like that. And then we had a couple other questions that had to do with proportions. Because similar triangles is all about proportions. Let's say x plus 3 over 4 equals 9 over 2. Question is solve for x. So when people would set this up, they would do this. They would say 9 times 4 equals 2 times x plus 3. So they would do this. 2 times x, which is 2x, and then plus that 3. Do you see what's wrong with this? Hopefully when you see this, you realize that they have to, look, you're doing 2 times x plus 3. 2 times x plus 3 equals 9 times 4, which is 36. This is not equal to this because you have to distribute this 2 to the 2x, but you also have to distribute the 2 to the 3, which is 6. Now watch. If I were to solve minus 6, I get 2x equals 30, x divided by 2 equals 15. Okay, now let's see if this is actually the answer. It is. Watch. When I plug it back in, 15 is equal to, 15 plus 3 is 18. 15 plus 3 is 18 over 4. Does this equal 9 over 2? 18 times 2 is 36. 9 times 4 is 36. Or I can reduce both of these, divide both of these by 2. 18 divided by 2 is 9. 4 divided by 2 is 2. That's what this answer represents. When you plug it back into the original equation, it has to work out and it has to make sense. Okay, so that kind of summed up everything that we did from chapter 2.